Hello everyone. So let's solve the next problem of the linked list playlist. That is the linked list cycle. Okay. So today we are going to solve this problem with two different approaches so that you would understand the basics behind linked list. Okay. So now given the head of the linked list, we need to determine if the linked list has a cycle in it. Okay. So there's a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Okay. Internally, POS is used to denote the index of the node that tail's next pointer is connected to. Note that POS is not passed as a parameter, so it is not known. Return true if there is a cycle in the linked list, otherwise return false. Okay, so basically what is asked in the question is that we need to detect if it has a cycle, and if it has a cycle, then we have to return true. Okay, suppose consider this example one. So as you can see that -4 is pointing to 2. So basically it forms a cycle. So we'll return true. Uh, in example 3, there is only one. So it is not pointing to any other node that is connecting it to itself. So uh, it will return false. So basically we need to return based on if there's a cycle or not. Okay. So what I can do, so like I can use a set basically to track all the visited nodes. Like I can start iterating over the linked list. I can use a set to track the visited nodes. And as I would traverse the linked list, I'll keep a record of all the visited nodes in the set. Okay. And if we encounter a node that we have already visited, suppose I encounter a 2 again, it means there is a cycle because we got that note again. Means we traverse through the list, but we are getting it again. And if we reach the end of the linked list, like if -4 would point to null, and if this connection would not be there, it means there was no cycle and we reached to the end. So we can directly return. So let's code this solution. Okay. So now, as I told that I'll use a set. Okay. So I can declare a set. What this set would store? This set would store all the nodes. Set would be storing nodes. Set equals to new hash set. Okay. Uh, so I'll take uh, a temporary variable as a head because I'll be traversing through the list and I don't want to lose my head. Okay. So I'll take suppose current as a new head. Okay. Now I'll start traversing the linked list. So while current not equals to null, right? It means that if I have traversed to the end of the list, if it doesn't have a cycle, then I should stop. Okay. So now what I'll do that if our set already contains this particular node, this current node. If it contains this current node, then we have a cycle. Suppose I started with 3. Okay. It doesn't, it is not in the set. So if it is not in the set, I'll directly add it to the set. Okay. So I'm adding it to the set. Okay. And I am changing the next current dot next. Okay. So now I'm in the next node. Okay. And uh, so suppose I started with this 3. So it is not in the set, so it will be added to the set. 2 will be added, 0 will be added, -4 will be added. Again 2 came. It checks. Does set already contains a 2? Yes, it contains a 2. So if it is containing a 2, means we have already encountered it before. So I can return true because there's a cycle. So I can return true from here. Okay. And if we pass the while condition, it means we are at the end of the list, right? We are at the end of the list means uh, the last node is pointing to null. So it means there is not a cycle. So I would return false. So I'll quickly run this code. So the base cases are accepted. Let's submit this. All right. So it's working. I know that it is not beating a lot of people. So let's try to optimize our solution. Okay. But firstly, let's discuss about the time and space complexity for this. So what will be the time complexity for this problem? So uh, so basically we are traversing the whole list once. Okay. So and visiting each node at most once. So the time complexity would be big of n, right? Because the hash set operation that we are performing, it take big of one time only. So the overall time complexity will be big of n. Okay. And what about the space complexity? So we used a hash set and we added all the nodes. So basically, n times. So the space complexity would be big of n because we need space for n different nodes. Okay. So now. So now let's follow another approach. Okay. So I'll comment this particular piece. Let's do another approach. Okay. So now, uh, how can I optimize it? So you have seen the pattern. Like if I take two different pointer, and basically the technique which I'm explaining is Floyd's tortoise and hare algorithm. So it is specifically for detecting cycle in a linked list. Okay. So now, and also it will not use an extra space. We can use two different pointers moving at two different speeds. Okay. So so what is the intention behind it? So I'll take a slow pointer, I'll take a fast pointer. Okay. Slow pointer will move one step at a time. One step. Fast pointer will move two step at a time. Okay. Now, now, if there is a cycle, if there is a cycle, the fast pointer will eventually meet the slow pointer. It will meet. Like consider this. I started from here. Slow pointer moves one, fast pointer moves two. Again, slow pointer moves to zero, fast pointer moves to two. Again, slow pointer move to -4, fast pointer move to -4. So now you see that these two meet. Even if the linked list could have been big, these two would meet, obviously. After like on in a single attempt only they'll meet. Okay. And if there's no cycle, the fast pointer will eventually reach the end, right? Will reach the null node. Make sense? So this algorithm would be much better. So let's write the code. Okay. So now with a base case, like if head is null or head dot next is null. So it means that there is a null node. I'll just remove this code. Okay. So I would return null from here. Okay. Not null. I need to return a boolean. So I would return a false. Okay. Because there is no cycle, right? Now, I'll take two different pointers basically. So as I was talking about, I'll take a slow pointer that will be starting from head. I'll taking a fast pointer that will also start from head. Okay. Now, when I have to stop until fast reaches the end. So while fast not equals to null, right? But like fast is moving at twice speed. So we need to check the next of the fast as well. Like if we jump too fast from here, so we are stepping two steps at a time. So we need to check the next of fast as well, if that is also null as well, because we don't want to encounter a null pointer exception. So I'll do fast dot next is also not equals to null. So I have to run my loop until that time. Okay. So slow will move one step at a time, and fast will move two steps at a time, right? So now slow will be slow dot next because it is moving one step, right? How will I make fast move two steps at a time? So fast will be fast dot next. So it is running two steps at a time. Makes sense? Now, at any time, fast and slow meet. That time we know that there's a cycle, right? As we discussed. So if slow is equals to fast. That means there is a cycle, right? Are you following me until now? Okay. So I'll return true from here because there is a cycle. And if after this loop, if fast reaches to the end of the list, like if there is no cycle, then we know that this loop will terminate because it will never go into this condition if condition. So I will return false. So this false will basically indicate that there is no cycle. So let's run the code. Okay, the base cases are running fine. All right. So you see like how our code is optimized. So like in the first attempt, maybe the code is not beating a lot of people, but uh, like we should be able to write some algorithm so that we could optimize it. We could build our thinking around that. Okay. So now, what will be the time complexity for this approach? So the time complexity would be big of n only. Okay, like both the pointers traverse the list at most once, right? But here the space complexity is big of one. Like in the last problem, in the last approach, we were using a hash set, so it was big of n. But in this case, the space complexity would be big of one because no extra space is used. Only two pointers are used. Okay, so this is an optimized approach, and you know how this program is running. Okay, so I hope you got the solution, and I'll see you in the next video. Make sure to like, subscribe, and follow my channel. Okay. Until then, have a good day. Bye.